All right, guys, so today we're going to go through the Chapter 10 review together. We're going to start out with the first section that we did, 10.1. Use the diagram to give an example of the term. On the test, you will be given a diagram, a word bank, and then I will ask you for like line AF, and you would have to match that word from the word bank. Okay. So here, number one, a radius. I have several to choose from. I could either choose FK or KJ. It doesn't matter. We'll just say KJ. So segment KJ. Number two, we want a common tangent. Remember that a common tangent is a line that touches more than one circle and only one spot on the outside. So in this picture, the only common tangent we have is AF. And so AF, and I would have to name it with the arrows. Number three, a tangent. The only tangent in this picture that is not a common tangent is line DC. Number four, the secant. Remember, secant is the line that crosses through the circle and touches the circle twice. And so in this one, I would call that line EH. Number five, I want a center. Again, in this diagram, we have two to choose from, either point B or point K. It doesn't matter which one we go with, so we'll just say K here. Number six, the point of tangency. Again, in this picture, you have several to choose from. You have point C, you have point A, or point F. It doesn't matter which one. I'll just choose point A. We need a chord. Remember, a chord is one that has its endpoints on the circle and then just connects those two. So I'm going to use chord GH. But remember that when I write it, I'm not looking at the whole line because that whole line would be a secant. So I'm just doing the segment bar notation on top. And then finally, a diameter. The diameter here would be FJ. Again, I can either use segment bar notation. All right, so then the next thing that we talked about in section 10.1 was finding the value of the variables when P, Q, and R are points of tangency. And remember that if it is a point of tangency, they're telling me that at that point, I know that I have a right angle. So if we look at number 9 here, I know that Q is my right angle because that's my point of tangency. And then these are just all doing Pythagorean theorem. So remember Pythagorean theorem, it's going to say R squared plus this whole side, 5, equals the entire hypotenuse. I have to add those together. So it's parentheses R plus 3 quantity squared. So here I have R squared plus 25. Now remember the R plus 3 quantity squared. That's either multiplying R plus 3 times itself, or I taught you that shortcut method. So the shortcut method says take the first term and square it. So that would be R squared. Now I multiply the two terms together and double it. So 3R doubled would give me plus 6R. And then finally the last term squared. So 3 squared gets me 9. I have R squared on both sides. So when I move one of them over, it's going to cancel. So now I have 25 equals 6R plus 9. I'm trying to get R by itself. So I'm going to subtract 9 from both sides. That gets me 16 equals 6R. When I divide, 16 divided by 6, it's not a nice whole number, but I can reduce that. They both have a 2 in common, so I would reduce that to 8/3. So on number 9, my answer R equals 8/3. So now number 10, again, Q is a point of tangency, so that's my right angle. So we're going to do another one of those exactly like number 9. So here I would have R squared plus 4 squared equals the entire hypotenuse r plus 2 quantity squared. So now I have r squared plus 16 equals, doing my shortcut again, I would get r squared, multiply the 2 and the r together and double it, so that gets me 4r plus 2 squared is 4. Yet again, when I move my r squareds over, they cancel. And so I'm left with 16 equals 4r plus 4. I'm going to subtract the 4 over, so then I have 12 equals 4r. And this time when we divide, we get a nice whole number, r equals 3. And so then number 11, the picture looks different. I have two tangents. Remember that when I have two tangents on the outside, that they are congruent to one another. So I just set these equal. So I'm going to say 2x plus 7 equals 3x minus 5. I'm trying to get my x's together. So I'm going to have 7 equals, I'm going to move my 2x over. And so I get x minus 5. Add 5 over. So I get the x is equal to 12 on that one. Number 12 looks just like number 11. So again, I set these two equal. So I would say 9x squared plus x plus 1 equals x plus 5. I want to get all of my x's on the same side, but this time when I move this x over, they cancel. And so I have 9x squared plus 1 equals 5. I don't have to worry about factoring or quadratic formula here because I only have an x squared and not an x squared and an x. So my goal is to get x squared by itself. So move the 1 over and we get 9x squared equals 4. Divide both sides by 9. So I get x squared equals 4/9. That's not a nice whole number, but since I have to take the square root, I'm going to leave it like that. So remember, take the square root. When I take the square root of a fraction, I have to take the square root of the top and the bottom. I have x equals, remember, I put the square root in the problem, so two answers, positive and negative. On top, square root of 4 is 2. On the bottom, square root of 9 is 3. So positive and negative 2/3. They're both my answer because if I plug the negative in here, negative 2/3 plus 5, I'm still going to get a positive number. And when I plug it in here, I'm still going to end up with a positive number. So we would need both of those as the answer. Number 13, same thing. So I'm going to say x squared minus 7 equals x minus 1 quantity squared. I need to get rid of the quantity squared. So remember that means x minus 1 times x minus 1. So again, I'm going to do our shortcut. The first term squared, so x squared. Multiply them together and double. So negative x doubled is negative 2x. And then negative 1 squared plus 1. Again, on this one, when I move x squared over, it cancels. So now I have negative 7 equals negative 2x plus 1. Move this 1 over, so now I have negative 8 equals negative 2x. And when I divide, I get x is positive 4. Number 14, again, looks very similar, only this time I have two circles. It still works the same because they're both external tangents. So I set them equal. So 4x plus 7 equals 6x plus 9. I'm going to move the 4x over, so then I have 7 equals 2x plus 9. Move my 9 over, so I get negative 2 equals 2x. Divide, x is equal to negative 1. Again, I don't have to worry about that being negative because when I plug it in, I'm still ending up with a positive number. All right, let's look at the next section. Section 10.2 is where we learned all about our arc measures and identifying it as minor, major, or semicircle. So here they have asked me to determine whether the arc is a minor arc, a major arc, or a semicircle, and then find the measure of the arc. You will have to do both of this on the test as well. So you'll have to tell me if it's minor, major, or semicircle and give me the measure. So make sure that on the test you pay attention and you give me both answers. So if I look at number 15, arc ED, so arc ED is this arc. They're telling me that this little angle in here is 30. That's a central angle. Remember that central angle and minor arc have the same. So if that's 30, arc ED is also 30. So if we want, we could just go ahead and fill in everything that we know. This arc, this angle is 75, so that means that arc up there is 75. By vertical angles, this is also 75, so this is 75. We know that 75 and this angle right here are a linear pair, so if I do 180 minus 75, I find that this is 105. This whole arc over here would also be 105, but since I already know part of it is 30, I have to do 105 minus 30, and I find that this arc is 75. So now that I have all of those labeled, it's easy to come over here and answer the question. So arc ED, we just found was 30 degrees. And now I need to name it as minor. Remember that minor is anything less than 180. Major is anything greater than 180. And semicircle is half the circle, 180. So number 16, arc EB. So if I switch colors, arc EB, I'm starting here and I'm going all the way around. So I'm adding 75 plus 75, and that's going to get me 150 degrees. That's still less than 180, so that is minor. Arc EC, from here all the way around. So I'm adding 75 and 30. 75 plus 30 is 105 degrees, and still a minor arc. Number 18, arc BEC, so B all the way to E and around to C, all of those, it's everything except this one. So remember, I can add all of those up, or I can do 360 minus 105. Either way, I'm going to get 255 degrees. That's greater than 180, so that would be a major arc. The next one, arc BC, that's just this. So that's 105 degrees. That is minor. And finally, arc BCD. So arc B, C, and D. I see that as half my circle. So that's going to be 180 degrees. And that is a semicircle. All right, so next part of section 10.2, now we have to draw our own circle. So they tell me that we have circle C. So over here, I'm going to draw a circle C. So C is in the center. It tells me that B bisects arc AD. So I know that I'm going to have an arc AD. B is going to bisect it. So in the middle of that is B. AE is a diameter. So there's my A. So here's E down here. And I'm going to go ahead. This was D. Sorry. I'm going to go ahead and connect these. They tell me that the measure of arc AD is 50. So this whole thing was 50, but remember that it got bisected. So this part is 25, as is this part, 25. So the first one, they want the measure of arc AED. So that is coming over here, A, E, and D, all the way around. It's including everything except the 25 and the 25. So to find this, I'm doing 360 minus the 50. And I'm left with 310 degrees. This one didn't ask me to name it, so it's just asking for the measures. The next one, arc BD, well, this is BD right here. That's 25 degrees. The next one, arc DE. So DE, this part I know that this whole side is a semicircle. I know that these two are 50, so 180 minus 50 is how we're going to find this, and that's going to give me 130 degrees. And finally, our last one, arc BAE. So this is BAE. I know all of this is 180. This is 25. So 180 plus 25 is how we're getting that. I'm sorry. BAE. So 180 plus 25. We get 205 degrees. All right, so next we're going to move on to section 10. So in section 10.3, we were finding the measure of arcs. So number 25, I see that I have chord AB is marked congruent with chord BC. So that tells me that these two arcs are congruent. I know the entire circle is 360. So we're going to start out, we're going to do 360 minus 130. That gets us 230 degrees. So these two together are 230. But since they are congruent, I cut them in half, and I find out that each one is 150. Number 26, I want arc AB right here. I see that I have the diameter, and it's perpendicular to this chord, so that tells me that to cut the chord in half, which also means it bisects the arcs. This whole side is a semicircle. I know this part is 125, so if I subtract 125 from 180, I get this arc. So 180 minus 125 gets us 110 degrees. Right. 180 minus 125, sorry about that, is not 110. 180 minus 125, how about, is 55 degrees. If this arc is 55 degrees, this arc is also 55 degrees. Number 27, again, I see that I have a perpendicular and it is marked congruent, so I know that these chords are also congruent. I also know this is a semicircle because now I know this is my diameter. So if I do 180 minus 135, I get 45 degrees. So I know that that arc AB is 45 degrees. All right, so let's flip it over. Section 10.4, this is where we had our inscribed angles, intersected arcs, and inscribed polygons. So if we look at number 31, we see that we have an inscribed triangle. I see that this is my center. They've marked that, so this is my diameter. So then we have the theorem that tells me that the angle across from that is my right angle. So now I know that x is equal to 90 degrees. I can now find y because I know all three angles have to add up to equal 180 because it's a triangle. Since this one's 90, I know these two together have to equal 90. So y equals 90 minus 40. So y is 50 degrees. Number 32, I have angle x in there. It intercepts this arc, 140. Remember that my inscribed angle is half my intercepted arc. So 1/2 of 140. So x is going to equal 70 degrees. Now y in here, this is angle y that I'm looking at right here. Y intercepts this arc up here. If this angle right here was 20, double that right here gets me that arc. So 20 doubled is 40. So angle Y is half of 40. So Y is 20 degrees. Number 3, if I look at the 2x minus 5, 2x minus 5 intercepts this arc, but so does the x plus 20. They both intercept the same arc. Remember, if they intercept the same arc, then they are congruent. So just set those equals. So I'm going to say 2x minus 5 equals x plus 20. Get all of my x's on the same side. So now I have x minus 5 equals 20. So x equals 25. If I look at the y's, y plus 27 intercepts this arc. They told me that that arc is 4y plus 10. So y plus 27 is equal to half of that arc. So 1/2 arc 4y plus 10. If I want to get rid of this 1/2, I could either multiply everything by 2, but then I have to multiply everything over here by 2, or I can just distribute. Since these are nice numbers that will go into what that 1/2 will go into, let's just distribute the 1/2. So we get y plus 27 equals, so half of 4y gets me 2y, half of 10 gets me plus 5. Move this y over, so now I have 27 equals 2y plus 5. Subtract 5, so now I get 22 equals 2y. And divide, y is equal to 11. Well, let's do that one again. Sorry, I just realized that when I subtracted this y over, it is not 2y, so we're going to erase that. So sorry, guys. My mind is somewhere else right now. I apologize. Let's try that again. So at this stage, when I move this y over, I get 27 equals 1y, so just y plus 5. So now subtract 5, and I get that y is just 22. All right, so now let's look at number 34. It's an inscribed quadrilateral. Remember, we have the theorem that tells me that if it's an inscribed quadrilateral, that my opposite angles are supplementary. So x and 75 are opposite, so they have to add together equal 180. So x plus 75 equals 180 degrees. So then when I solve that, I get the x is 105 degrees. Y and 95 are opposite, so y plus 95 has to equal 180. When we solve that for y, we get y equals 85 degrees. We're going to do the same thing on number 35. I'm going to switch colors just so that we can tell the difference here. So 9x and 117 are opposite. So 9x plus 117 has to equal 180. Subtract 117 from both sides. So then I get 9x equals 63. Divide both sides by 9. X equals 7. My 83 and 7y minus 1 are opposite angles. So 7y minus 1 plus 83 has to equal 180. Combine negative 1 and 83, so I have 7y plus 82 equals 180. Move my 82 to the other side, so I get 7y equals 98. And divide, so I get y is equal to 14. So next we're going to move to section 10.5 here. We had all of these different formulas. I'm going to have all of these formulas on the board for you. So we'll pull up that sheet that has all of the formulas from 10.5 and 10.6. So you don't have to memorize these for the test. So number 37, I have two chords. I'm looking for this angle in between. So my formula says that that angle x is equal to 1/2 the two arcs added together. So 1/2 55 plus 35. So here if I add 55 and 35, I get 90. So x is half of 90. So here x is 45 degrees. Number 38, this is the angle they give me, but these are the arcs they give me. So first I need to find this angle here. We'll call that y right now. 138 and y are a linear pair. So 180 minus 138 is going to give us that angle. So that angle is 42 degrees. So now I can say 42 is equal to 1/2 these two arcs, x plus 50. I want to get rid of that 1/2, so I'm going to multiply everything by 2. So I have to remember to multiply the 42 by 2. So that gets me 84 equals x plus 50, because my 1/2 and my 2 cancel. So subtract 50, so I get x is equal to 34. If I look at this one below it, number 40, I have this angle 75, this arc 5x, this arc 12x plus 3. And the angle I know is on the outside, that angle 75 is equal to 1/2 the big arc 12x plus 3 minus the little arc, so minus 5x. So right now I have 75 equals 1/2. So 12x minus 5x leaves us with 7x plus 3. Again, so we don't have to distribute the 1/2 and get fractions in here. We'll multiply everything by 2. I have to remember to multiply the 2 times the 75 as well. So that gets me 150. Here my 1/2 and my 2 cancel, and I'm just left with 7x plus 3. Subtract 3, so I get 147 equals 7x. Divide both sides, and I get x is equal to 21. Again, they give me this angle here. I don't know my big arc, but I know this arc and this one. All of them together have to equal 360. So if we do 360 minus 110 minus 92, that's going to get me this arc right here, which I'm calling y, which is 158. So now I know this is 158. So now I'm going to set this up. 10x plus 3 equals 1/2. The big arc we just found, 158, minus this little arc, 92. So now I have 10x plus 3 equals 1/2. So if I do 158 minus 92, I get 66. I can take half of 66, so 10x plus 3 equals 33. Subtract 3 over, so I get 10x equals 30. Divide by 10, x is equal to 3. If I look at these below it, and then we'll go back up and do those other two. So here I have 2 tangents. So remember that if I have 2 tangents, I take the outside portion, 5, I multiply that by the entire length. So 5 plus 3, 8. That's equal to the other outside portion, 4, times the whole length, x plus 4. So here I have 40 equals, I want to distribute my 4, 4x plus 16. I'm going to subtract 16 from both sides, so then I get 24 equals 4x. And when I divide, I get x equals 6. On this one, I have a secant and a tangent. I take the tangent and I square it, so 12 squared equals the outside part, 8, times the whole thing. So 8 plus 1 is 9 plus 3x. I want to distribute that 8, right? On this side, 12 squared is 144. When I distribute my 8, I get 72 plus 24x. Subtract 72 from both sides, so I get 72 equals 24x. Divide both sides by 24, and I get x is equal to 3. Number 48 is another one just like that. So I take just the tangent, and I square that, but this time I have to square both of them. 2 and the x is equal to the outside part, x plus 2, times the whole thing. So x plus 2x gets me 3x. 2 plus 5 gives me plus 7. On this side, 2 squared is 4. X squared is x squared. Over here, I need to FOIL, right? So x times 3x gets me 3x squared. X times 1 gets me plus x. 2 times 3x gets me plus 6x. 2 times 1 plus 2. I'm going to go ahead and combine like terms over there. So right now I have 4x squared equals 3x squared plus 7x plus 2. My x squareds are not going to cancel, so I want to move everything over, get everything on the same side. So when I do that, oh, I am so sorry. Again, I thought that was a 1. That's a 7. So that's going to change those in just a second. That's a plus 14. 7 times 2 is a 14. My pen didn't write all the way, so it was hard to see that. So this is plus 14. So I'm going to move everything over. So when I subtract 3x squared over, 4x squared minus 3x squared gets me x squared. I'm going to move my 7. So that's going to be, make this a 7x as well. Sorry. So this was really 7x and 6x is a 13x. So I'm going to subtract my 13x over and my 14 over. All of that equals 0. Again, since I have an x squared and an x, I need to either look to factor or quadratic formula. I'm always going to see if I can factor. This one factors easily. Right? I'm looking for what can I multiply together to get negative 14, but add to get negative 13. That's going to be a negative 14 and a positive 1. So my parentheses, I'm going to have x minus 14 and x plus 1 equals 0. When I solve both of these, they just come out opposite. So I get x equals 14 and x equals negative 1. Again, what is my x representing? A length. Up here, if I plug in negative 1, 2 times negative 1 is negative 2. I can't have the negative. So I'm only looking at the positive 14. All right, I'm going to scroll back up and do these two that for section 10.6. So I have 2 chords inside. Remember that the chords, let's see if I can get rid of that. The chords here, let's find a color that we haven't used over here. So the chords, I multiply each part of the chord together. So the first part is x, gets multiplied by 15. So 15x equals 6 times 5. So we have 15x equals 30. So x is equal to 2 on that one. This other side, again, this chord has the 12 and the 5. So I multiply 12 times 5. I set that equal to 10 times x plus 1. So 12 times 5 gets me 60. Distribute my 10, 10x plus 10. Subtract 10 over, so I get 50 equals 10x. So x is equal to 5. All right, we're almost done. So now the very last problems. We learned these back in section 10.1. The circles. So this first one, find the center and radius of the circle. X plus 4 quantity squared plus y minus 10 quantity squared equals 36. Remember that if I don't have parentheses, then my center is at 0, 0. If I do have parentheses, my center comes out opposite. So my center of this one, I have a positive 4, so that comes out as negative 4. I have a negative 10, that comes out as positive 10. So there's my center. Remember, our radius, this last number is always our radius squared. So I take the square root of 36 and get 6. Our very last one, we're going to graph this circle. So we're going to come over here to this graph. Two things you need to graph the circle, the center and the radius. So my center, negative 1 comes out positive 1. 3 comes out negative 3. My radius, the square root of 4, is 2. So remember, to graph the circle, you plot the point of the center. So the point 1, negative 3. So I go over 1, down 3. There's my center. From that point, I do the radius, 2. So I go up 2, I make a dot. I go back to my center. I go left 2, down 2, and right 2. Remember, those are the points that I am connecting. Do not connect them with lines. Remember, this is a circle, so you want it to look round. All right, so that is your test review all worked out. Again, this is also filled out in the announcement on Canvas, so you can also go back and look at it all filled out on the announcement. So go back and look over anything that you had a question about. Get help from your neighbor, but make sure that you are good and ready to go for the test. Again, the formulas will be put up on the board for you. I hope you all have a great week. I miss each and every one of you, and hopefully I will see you next week. That's my plan. Take care, guys.